Alright, so let's talk about arithmetic sequences or progressions. And basically that's when you have like a list of numbers and some kind of difference between them, right? 3, 5, 7, 9. And these are various terms, right? This is the first term, the second term, the third term, the fourth term. And what you're looking for is you're looking for a term, and let's say you're looking for the 25th term, right? Well, clearly you could just keep going up using the sequence and counting as you went along, and that could take you the better part of a day sometimes. Or we could come up with a formula to use in which this will be unveiled pretty quickly. And let's work towards that. The formula itself is not too hard to remember. It's a to the nth, and the nth is just the term we're looking for. So it's what we're looking for is a plus something in parentheses, the nth minus 1 times d. And let's take a minute and talk about what all these various things represent. A to the nth is just the term we're looking for. A itself is the first term in the sequence. This one above, of course, would be 3. Plus the number of the term we're looking for. Again, above we were looking for the 25th term. Minus 1 times d. And d was the difference. What was the difference? The constant difference that happened in an arithmetic sequence. The common difference was 2, right? Not to be confused with geometric sequences, which is another video coming up. But this is the arithmetic sequence, the constant difference. All right? So let's use this strand of numbers and input it into our formula, and let's see if we can come up with an answer. So let's just say the a to the nth is what we're looking for. That's going to be our answer. Our first term is 3, plus the nth term we're looking for is 25, right? 25 minus 1, says the formula, times d. And d is the difference. D is 2. All right. If we work that out further, of course, as we should, first things in parentheses, PEMDAS tells us, the order of operation tells us, that's what we're doing. So let's pick a color here and fill in what we have. 3 plus 25 minus 1 is 24. And that still times our 2 that's out here, because 2 in the order of operations would be next. All right. Let's fill out this whole range of numbers here, and we get 3 plus, what is 24 times 2? 24 times 2 is 48. And 3 plus 48 is equal to 51. And if we were to take this formula, or rather this strand of numbers, and take it out 25 places, where would we end up? 51. And 51 is our answer. That's simple. All you have to do is know the formula, know what each piece of the formula means, and then just input the numbers into the formula like we did here, and solve it. 51 is the 25th term in a strand of numbers that starts off 3, 5, 7, 9. All right, good luck. Now let's move on to geometric sequences. All right, so here we're talking about geometric sequences. And those are sequences that, let's say we have another strand of numbers and we're using, sorry about that, 2, 6, 18, 54, and we're looking for the geometric progression of these. We can see that between 2 and 6 is 4, but we can't add 4 to 6 and get 18. So something geometrically must be happening here. And it just takes us just a brief minute to realize that we're multiplying each by 3. That each time we're taking the number and multiplying it by 3. And so that's a issue where we're going to have geometric sequences, and we're going to need a very specific formula for this. And of course, you're in luck, we have one. So a to the nth again, a to the nth, or the term we're looking for, is going to be equal to a times r raised to the nth minus 1. And no panic here, we know what these are. This is what we're looking for, right? A is the first term, in this case 2. A is the first term, 2. R is the geometric progression or the impact in between each numbers. It's called the common ratio, right? So let's just write that down. It's called the common ratio. And That's important. So this here, this r is the common ratio. In this case, it's a 3 raised to the nth term, the one we're looking for, minus 1. So let's just do a little quick math and see what we come up with. Let's say we're looking for the 5th term. Let's say we want the 5th term. Put that over here, the 5th term. All right, that's the unknown in this case. And all we have to do is fill out our work. We're going to say something we're looking for is equal to, what's the a, right? The a is 2. It's the first term we have. And we're going to multiply that by 3, which is the progression, the common ratio. Remember, 3 is our common ratio. And 3 raised to the nth minus 1, right? Which we know is actually 5 minus 1. And so then we have, so the next step would be 2 times, what is 3 raised to the power of 4? 81. And 81 times 2 is what? It's 162. So 162 in a geometric sequence, 162 is the 5th term. We took the formula we know, plugged into that formula what we needed to, and got 162. So give this a try, get some practice. It's not that hard, just needs a little bit of repetition. And if you're registered with My Teacher CT, go online to your site, look for some worksheets, or send us an email. We'd be happy to send you some out. But you'll be able to get through this. So enjoy the day, and let us know if you need anything. Take care.